So in the last video we have done up to question number 16 for the NEET exam. So let us continue rest from question number 17. So what question number 17 tells, I am giving you the paper. It tells that a conducting loop of finite resistance. I am just reading it out. A conducting loop of finite resistance lies in the xy plane. There is a constant magnetic field. B is constant. The magnetic field B is equal to constant. And the area of the loop varies at time t. Area is varying with the time t A0, 1 plus sin t. So once B and A is given, you can find out flux. Flux is equal to B into A0, 1 plus sin t. Then if you want to find out EMF d phi by dt. So d phi by dt becomes B A0 cos t. What it tells, the graph, which graph correctly indicates the qualitative behavior of the power P dissipated in the loop as a function of time. Once you got EMF, power P is equal to E square by R. E square by R means B square A0 square cos square T by R. This factor is constant. So P is equal to say P0 cos square T. So P versus T graph is a function of cos square T. So if T is equal to 0, then this cos square T will be 1. So P is equal to P0. That means T is equal to 0. Power P must be equal to P0. Look at the 4 graphs. Your 4 graphs you look at, P is equal to 0. It should not be 0. Power should not be 0. P is equal to P0. Out of 4 graphs, this is constant, is not cosine function. This is 0. It will not happen. This is 0. It will not happen. It is a cosine function graph. So it has got something. So this is choice 4. So answer is choice 4. Answer is choice 4. So easily you can find out. Then question number 18. Question number 18. Question number 18. So what you do? A photon and electron each having 20 electron volt. Energy is same. 20 electron volt. Move in free space. The ratio of the linear momentum of electron to that of photon. PE by pH. You have to find out. You have to find out PE by pH. So let us see. When you write PE, you have to want to find out energy. Energy in PE. Okay. Now energy E is equal to, if energy V, momentum will be equal to root over 2me for electron. For photon, what I can write, momentum for photon, pH, is equal to energy by C. You know, E is equal to mc square, 1c cancel, or mc momentum, same thing. You have to find out a ratio, PE by pH. So PE by pH, root over 2me by E by C. C goes up, root over 2m by E. Just you have to calculate. You put the value of C, 3 into 10 to the power 8. And 2 into mass of the electron, 9 into 10 to the power minus 31. Okay. By energy, 20 electron volt. That is 20 into 1.6 10 to the power minus 19. This calculation part you do. You can do the calculation part. This ratio PE by pH. PE by pH is this you calculate. You see from here 10 to the power minus 19, this is plus. So plus means 12. Minus 12. Minus 12 root over means minus 6. Minus 6. This is plus 8. That means plus 2. This becomes 300. 9 into 2, 18. Then this is 32. So you do it, this becomes 300. 300 in the numerator is root over 18. 18 by 32. You divide by 2 becomes 9 by 16 means how much? Is equal to 3 by 4. So 300 into 3 by 4. 300 into 3 by 4. How much comes out? This is 300. Right, 3 by 4, that comes out is you have to calculate 900 by 4. So 900 by 4 means how much? 900 by 4 is equal to 225. So answer is 225. Answer. That is somewhere. The value is written as A. First choice A. 1. Choice 1. Now next is, let me just change the paper here. Next question is 19. Question number 19. Question number 19 is based on some unit and dimension. He writes sigma S as Boltzmann constant, sigma S. Sigma S as Stephen-Boltzmann constant. So in the Stephen's law, it is question number 19. Let me write. Question number 19. Now see what is energy. In Stephen's law, E expression is nothing but energy per unit area. Energy per unit area per unit time. That is equal to sigma into temperature to the power 4. Okay. Temperature to the power 4. Then you have to find out what is sigma. Sigma is equal to, you bring to denominator, energy by area. Area means how much? L square. Then T is time, theta to the power 4. Sigma, you got it. Next, one more constant is tells that one displacement constant or Boltzmann constant. So Boltzmann constant means energy is equal to 3 by 2 Boltzmann constant Bt into T minus temperature theta. So from here, you write what is 1 by kb. 1 by kb you need because your expression has been there, kb to the power minus 1. So 1 by, bring to left hand side, 1 by kb is equal to theta by u, energy. This is kb to the power minus 1. The next one is your Wien's displacement constant, that is B. Lambda into theta, temperature, is equal to B. Lambda is nothing but length, L. So next, that becomes equal to L into theta. Okay. Now sigma S, what you want? Sigma S, kb to the power minus 1 and B. You have to find out this dimension. Now sigma S is nothing but U by L square T theta to the power 4. Kb to the power minus 1, you have already got this one, theta by U. Energy. B is L theta. B is equal to L theta. Just see. Here U cancel out. 1 L will cancel out. 1 theta and theta square cancel out, theta to the power 2. So this becomes L to the power minus 1, T to the power minus 1, temperature K to the power minus 2. So you can see there is a choice, third choice. In a question paper, it is the third choice. The answer is 3. 3. Next one is question number 20. Question number 20. Two infinite long puzzle conducting where A and B carry current I and 2I respectively in the same direction. If the current carrying conductor, they carry current in same direction. Say one is I, one is 2I. There will be a force of attraction between them. Okay. Where A has a uniform cross section, A is carrying I, and B this is A, this is B. Okay. And A has a uniform cross section lambda, uniform mass per unit length. A has uniform mass per unit length lambda and lies on the insulated floor. That just reverse. It is not like that. This is B. This is your A. This is 2I. This is I. Okay. This is lying on the floor. That is attraction. If the force will be sufficient, it will be get lifted up from the ground. So the question is, the wire is kept at a height h. So distance between them is h. So what should be the minimum value of h so that a does not rise from the floor? Means just it is tendency to rise. So what is the attractive force? Let us write down. Let us write down what is the attractive force. You have to equate equal to the force because of the weight. So attractive force is mu 0, then I into 2I. Sorry, mu 0 into I into 2I, current, divided by 2 pi h, height is h. Here, this is the force per unit length. Right hand side, this is mass per unit length into G is a force per unit length, equity. You get the value of h. So from here, you get h. 2 cancels. That means mu I square divided by, here is pi lambda h. Sorry, pi lambda into G. H is equal to mu I square by pi lambda G. There must be some choice. It is there. Mu I square by choice 4. Pi lambda G, choice 4, answer 4. The next, 21. What 21 tells? Here, 21 tells which of the following measurement requires index correction. Number 1, see, index correction is a word used for laboratory measurement. Measurement of focal length of lens using optical bench. Yeah, this will be the correct answer. Second one is measurement of speed of sound using resonance tube. Here, it is end correction, not index correction. Measurement resistance using meter beams. That is also end correction. Measurement of gravitational acceleration due to simple polynomial. It is constant. You know, this is L and this is R. So correction is what? L effective is equal to L plus R. This is the correction. So choice is A. Choice is 1. 1 is the answer. Index correction is used when the zero marking of the scale doesn't match with your initial reading setup. So this is your question number 21. Theoretical question. Question number 22. Look at question number 22. One diagram, 2 inductors are in series. Here 2 inductors are in parallel. So if it is series, same current will flow through both of them. If it is parallel, that I will be divided I by 2, I by 2. So what it tells that he is finding out what? He is finding the induced EMF. Induced EMF is what? L di by dt. So question number 22. Induced EMF for P, L di by dt. That is induced EMF of P, induced EMF of P. Okay, L di by dt. Now, what is induced EMF P, EP? What is EP, EQ? For EQ, what happens here? Because they are in parallel, I by 2, I by 2. So this induced EMF is same across the combination. Same, but here is L d I by 2. Current is I by 2. So EQ is equal to L d I by 2 by dt. That becomes half L di by dt. So now he wants to find out something ratio or something like that. Okay, what he wants to find out? EP by EQ. EP by EQ is equal to, it is L di by dt divided by half L di by dt becomes equal to 2. The answer is 2. Choice is 2, B. Choice is B. Okay, that is 2. Next question. Question number 23. Is a theoretical question. You can see I am putting the question here. There are 3 diodes, but battery positive is connected here to cathode. but here it is to anode. And middle diode is not connected. That means no battery supply across this. Because it is connected to D3 in cathode, it is reverse bias. So its your depletion region width will be maximum. Because it is forward biased, D1. Okay, this is something D1. Okay, D1. This depletion region is width because it will reduce because it is forward biased. Because it is not connected, so it will be the normal whatever depletion region is there. That means what depletion region width W3 is maximum and W1 will be minimum because forward bias. In between will be W2. See the choice. W3 maximum, that is W3 maximum, W3 maximum, that is greater than W2, normal, no voltage. And from normal, it will reduce because of the application of the voltage. So that is greater than W1. So choice is 1. So W2, W3 greater than W2, greater than W1 is the answer. That is choice here 1. Choice 1. Come back to the next question. 24. 24, no? Let us see next question. Here what it tells, two capacitor series, here it is across parallel. So what it tells that voltage V has been applied. He has told that if energy stored in the capacitor P and total energy in the system is UP. So energy stored in the capacitor is UP, P is UP and total energy stored is UT. You have to find out UP by UT. Here it is a very simple question. There is nothing much. It is 24. So here what you get, energy stored in P is, you can see this entire thing, voltage V has been applied. So across each one of these V by 2, V by 2. Energy stored in P will be half C into V by 2 square. That is your energy stored, which that becomes CB square by 8. Now, total is what? Energy stored is here across it and one more parallel. Here it is half CB square and plus energy of this plus energy of this. Energy of this half C into V by 2 square, like this. There are two numbers into 2. 2 cancels, you can half CB square plus CB square by 4. That means becomes 3 by 4 CB square. This year total, E total. And this year EP. You are required to find out, sorry, E in a UP. UP and UT. You have to find out UP by UT. So this becomes your UP is equal to CB square by 8. And this becomes your 3 CB square by divided by 3 CB square by 4. By divided by 3 CB square by 4. So 4 will go up 3 CB square. CB square cancels out. 4 and 2 will cancel, 1 by 6. So it becomes 1 by 6. So choice you check. Choice 2 is 1 by 6. Choice 2. So complete 24. Let us go to 25. Let me change the paper. Let me change 25. Question number 25. What it tells? There is a disk rotating and there are 2 points taken on this axis A and B. If you want to find out angular momentum, LA and LB. Here angular momentum is LA, here is LB. How do you find out? Angular momentum at A is at A. Nothing but your whatever angular momentum is there, I0 omega. Okay. Plus R plus P. But this R plus P factor is 0 because it's not translating. So I0 omega. L suffix P is same thing. I0 omega plus R plus P. But R plus P again 0 because translation is not there. So it's same I0 omega. That's why both are same. So LA is equal to LB. So what he wants to find out? LA by LB. LA by LB is equal to 1. LA by LB is equal to 1. Choice is A. First choice. Question number 26. Question number 26. Let me change the page. Okay. Here is a very simple question. Here he is asking battery voltage here given as minus 5 volt and general breakdown voltage is minus 3 volt. He wants to find out what is the voltage drop across the resistance. That is 5 volt minus 3 volt, 2 volt. The answer is 2 volt. Choice 4. It is choice 4. So, choice 4 is the right answer. One line problem. Question number 27. He gives you something like your variable cross-section tube and water is flowing, some fluid is flowing. Some fluid is flowing. 2 points you take it. Here pressure is P1, here pressure is P2, velocity is V1, here velocity is V2. Height is of course same. The pressure difference, what will happen? P1 minus P2 is equal to half rho V1 square. Half, it will be half, one relation is given. That is your cross-section is given. The cross-sectional pressure difference is 15. This pressure difference is 15 given. And cross-sectional area, P and Q are. So here cross-sectional area is how much? 40 centimeter square into velocity V1. Most equal here cross-sectional area is how much? 20 into V2. From here what you find? V2 is equal to 2V1. That relation one you got. 2V1. Now, pressure depends how to find Bernoulli's equation. Rho GH here and rho GH here is same. So P1 minus P2 is equal to half rho V2 square minus rho V1 square. So P1 minus P2, which is 15 given, is equal to half rho V2 square minus V1 square. But V2 is how much? 2V1. So it is half rho. It is equal to 2V1 square means 4V1 square minus V1 square means 3V1 square. So 15 is equal to half. Of course, rho is given. Rho is given how much? 1000 MK unit. It's 3V1 square. 3 into V1 square. Okay. This is equal to 500. 500 into 3. 15 is equal to 500 into 3 and 500 V1 square. So V1 is equal to 1 by 100 root over 1 by 100 is equal to 1 by 10. So you got V1 1 by 10. This is meter per second, of course. Okay. Now that is equal to how much? In centimeter. 10 centimeter per second. Quantity of liquid flowing is how much? Cross-sectional area into velocity. A1. A1 into V. But what is A1 V1? A1 is equal to here how much? Oh, that is equal to 40. 40 into V1 is how much? 10. That is equal to 400 centimeter cube per second is the answer. Yes, choice is there. Okay, choice 2. Answer choice 2. Now we have covered 27. Let us go to next page. 28. Now what 28 says? Now what 28 says? A particular mass m moves along a horizontal axis from x is equal to 0. Question number 28. Particle is going from a point x is equal to 0 to x is equal to L. Particle is traveling. Okay. Then what it tells, it has a coefficient of kinetic friction mu as a function of x. Mu k as a function of x is equal to mu 0 minus alpha x, where mu0 and alpha are constant. One more data is given. Mu L is equal to 0. Mu KL. When x is equal to L, that is 0. Is equal to, here it is mu0 minus alpha into x is equal to L. So from here, mu0 is equal to alpha L. So find out alpha, mu0 by L. This I have done because in the entire question there is no term called alpha. You have to eliminate. Come back to here, mu k. Mu k x is equal to mu0 was there minus alpha has come out to mu0 by L into x. You take mu0 common, 1 minus x by L. Then what is frictional force? Mg into this one. Mu0 into 1 by x by L. This is the frictional force. Into displacement dx is the work done. So total work done is from 0 to L. This is what you want to find out, total work done. So we have to find out work done against friction. So here, mu0 mg gone. This becomes x minus x square by L, 0 to L, is equal to mu0 mg. This becomes L minus L square by L. This is L square by L means how much? L square x square. This becomes x square by 2. This becomes x square by 2. So it is L minus L square by L. That is L by 2. That's equal to L by 2. Mu0 mg L by 2, half. Okay. Now he has told expression. That expression is, what is given by expression is given some expression. N mu0 mgl. As per question, it is N mu0 mgl. So we want to find out value of N. So N value is nothing but half. So N is equal to half. Choice is how much? B. Second choice. So you have completed how much? 28. So this page is gone. Then you have to find out 29. Question number 29. Number 29. A ray of light of wavelength of lambda incident on the 3 different photoelectric cells, namely 1 to 3. The threshold wavelength of this photoelectric cell. The threshold wavelength of photoelectric cell is how much? Lambda 1, lambda 2, lambda 3. Threshold wavelength. And magnitude of stopping potential is V1, V2, V3. For this V1, for this V2, for this V3. Then he finds the relation between lambda and threshold wavelength. Lambda 1 less than lambda is one condition. Lambda 2 less than lambda is another condition. Lambda 3 much greater than lambda, another condition. So for these conditions, what will be the stopping potential? Einstein's photoelectric equation. Einstein's photoelectric equation is EV is equal to SC into 1 by lambda minus 1 by lambda E. Or lambda 0. That is your stopping wavelength. Now, if lambda becomes greater than or less than lambda greater than or less than the lambda 1, right? Lambda 1. That means the wavelength is shorter wavelength. Then emission will take place. But if lambda becomes greater than lambda 1, then no emission takes place. If no emission takes place, the stopping potential will be 0. That means no emission. No emission means stopping potential V1 will be 0. Lambda 2 given, how much? Lambda 2 is less than lambda. Less than lambda. That means what? Lambda 2 less than lambda means lambda 2 less than lambda. That is given or what? Second condition in the question, what is given? Oh, lambda 2 greater than lambda, not less than lambda. It is given lambda 2 is greater than lambda. Is greater than lambda. If lambda 2 is greater than lambda, that means lambda less than lambda 2, then emission takes place. Emission takes place means V2 will be finite. V2 is finite. The next one is V2 is finite or greater than 0. V2 is greater than 0. Third condition is given lambda 3 much greater than lambda. That means here lambda 3 much greater than lambda means the other way you can tell lambda is much less than lambda 3. So here V3 will be what? V3 will be greater because V3 is greater than V2. Because it is much greater means lambda is much less than this. So more higher energetic electrons should come out to stop it more potential. More potential means V3 is greater and V3 greater means V3 is greater than V2. So one condition is V3 greater than V2, other condition is V1 0. So what are the conditions given? Given is you see what are the conditions given? Third choice. Third choice is V1 is equal to 0. That we have already got. And V2 less than V3. So here same thing. V3 greater than V2 means V2 less than V3. So this is the correct answer. This is the correct answer. Question number 30. Consider that an electron revolving around an excited state of hydrogen atom with velocity v is equal to root over 25/6 in 10 to the 5 meter per second. The radius of the orbit is x into 10 to the 5. Radius of orbit is x into 10 to the minus 9. X, you have to find out x. Mass of electron is given, charge of electron is given. Okay. Now, here we know that mv square by r, therefore must be equal to 1/4π/0 e square by r. E square by r square. So here what happens, what you find out, one r cancels out. You just find out m, v square r. So what is v square r? If you v square r, this m factor comes to right hand side. 1/4π/0 9 into 10 to the 9. Okay. E square means 1.6 into 10 to the minus 19, that whole square divided by. That mass factor comes. Isn't it? This mass factor, how much mass is given? That is given 9 into 10 to the minus 31 kg. Just calculate v square r. So v square r comes like this. But v value is given 25.6, 10 to the 5. So square it. It becomes your 25.6 into 10 to the 5 square, 10 to the 10 into r. That is equal to this 9 cancel. 10 to the power 9. 1.6 means this becomes 2.56 square into 10 to the power minus 38 by 10 to the power minus 31. So from here you solve it, get the value of r. This thing you take to right hand side. R value will come out is equal to 1 into 10 to the power minus 9 meter. So here, as per the question, you have to find out x. He has given x into 10 to the power minus 9. That x value equal to 1. So x equal to 1 is the answer. And your choice is second choice. So 30 you have covered. Next one is question number 31. Question number 31, let us see. What it tells. My car travels in a circular track of radius r is equal to 50 meter, which is banked at angle theta, banking angle theta. The car travels at a speed of 10 meter, v is equal to 10 meter per second. 10 meter per second. Then the wear and tear of the tire is minimum, taking the acceleration due to gravity G is equal to 10 meter per second square. Okay, the value of banking. If you remember the formula well and good, otherwise you can derive also. This is a bank tag. Vehicle is there, normally action. This side, this angle theta. Draw the vertical line through it. So this angle theta. Component normally action. This side is n cos theta. That must balance mg. One component n sin theta. Must balance mg square by r. So you got n sin theta is equal to mb square by r, and n cos theta is equal to mg. You divide it both sides. Automatically you get tan theta is equal to b square by rg. You have to just put the value. B is 10, so square is 100. R is how much? 50. G is 10. The 500. 1 by 500 means 1 by 5. So tan theta is equal to 1 by 5. And the choices are given tan inverse. Okay. Theta is equal to tan inverse 1 by 5 as per your choice. Choice number 3. Answer choice number 3. So question number 32. Question number 32. Here I think it's a PV diagram. A PV diagram is given. So here is 2. Here is 3. Okay. It is volume. Here pressure 300. The pressure 300. 300. 1 mole of an ideal monoatomic gas undergoes cyclic process. In the cyclic process, what happens? Delta U is equal to 0. Delta Q becomes equal to delta W. You want to find out total heat supplied. Heat supplied is equal to work done. Work done means area under the graph. Area under the graph is PdV. Pressure difference how much? 300 minus 100. This side 200. So work done is 200 into volume is 3 minus 2. That is equal to 1. Okay. So how much is equal to? Comes out equal to 1. That is equal to here. What else is called heat supplied? Okay. Here heat supplied. Okay. This factor is not 3. It is 5. That is why problem. This is not 3. This is 5. So 5 minus 2 is 3. 3 into 200 is 600. Equal to 600 joule. Choice, let us see 600 is first choice. Okay. Let me change the paper. It is 32, then we will go to 33. We will go to 33. Question number 33. Let me find out when. What 33 tells? Question number 33. This is the next page. Okay. What it tells that here is a frictionless circular wire. Here is a circular wire. Is a vertical line. Okay. Then what it tells? Radius of the frictionless plate, 2 points. Particle of a unit mass starts moving simultaneously from the point theta is equal to pi by 2. So if you understand this is your theta value, theta is equal to pi by 2 means this point. If this is theta, make it pi by 2 means here is 1 point. So two particles moving with uniform angular velocity in opposite direction. One is moving in this direction, other one is moving in this direction. So for one particular velocity, tangential velocity is this side v, other side tangential velocity also v, because omega is same and r is same. So r omega velocity, tangential velocity is same. Okay. And which of the following figure schematically represents the magnitude of the total linear momentum p of the system as a function of time theta? Problem is whatever thing you find out is the boundary condition. Initially, when theta is equal to pi by 2, theta is equal to pi by 2, initial condition. Momentum one is mb towards right, other one is towards left. Momentum is mb minus mb is equal to 0. Check up the possible points in the graph. In the graph, there are possible at t is equal to 0, pi by 2, it should be 0. T is equal to pi by 2. It t is equal to, it's not 0, it is finite value. It is also finite value. It is also finite value. Only one diagram is there when momentum is 0 at pi by 2. The choice is 1. So first choice. So choice is 1. The answer is first choice. The next is question number 34. Let me change the page. For 34 relates to a lens combination. Here is one lens and here is another concave lens. Distance is 3 centimeter. Okay. Distance 3 centimeter. Focal length of L1. This first lens. This focal length F1 is equal to 10 and this focal length F2 is equal to minus 10. Then it tells that the position of the image, the object is kept here as minus 30 from this side. From this side is minus 30. So convex lens will form an image 1 by b minus 1 by b minus of minus 30 is equal to 1 by f. 1 by f means 10. So 1 by b is equal to 1 by 10 minus 1 by 30. How much comes out? This becomes 30. 3, 12 to 1 by 15. So b becomes equal to 15 centimeter. So from here to the right, b is 15 centimeter. But this gap is, lens to lens gap is 3 centimeter. That means object distance for the concave lens is 15 minus 2. 15 minus how much? 3 is equal to 12 centimeter. Object distance for the concave lens. Then for the concave lens, you write down 1 by b minus 1 by minus 12 was equal to focal length is minus 1 by 10. 1 by 10. So it is 12 centimeter to the right. Right means it was positive, not negative, it was positive. So that 1 by b becomes equal to minus 1 by 10. It will be plus 1 by 12. How much it will be? It will be, say, 60. And this will be minus 5 plus minus 6. And 6 plus 5. Minus 1 by 60. 1 by 60. So b is equal to 60 centimeter. Minus 60 centimeter. You can see b is equal to minus means what? To the left of this lens. So it comes out to be equal to how much? 4. Choice 4. Choice 4. Answer 4. So you have completed how much? 34. Okay. You have done 34. So we will stop here. Then another video will complete it.